Hello students. In the last class we were discussing the different name reaction alphabetically. Already we have completed some important name reaction. Today we will discuss remaining name reaction, which is very much important for your examination. So let us start. That is 14. That is esterification. Esterification here, ester can be prepared from acid and acid derivative in presence of alcohol, and the catalyst is sulfuric acid. Product is ester, CO, gas and water. This is called esterification. Already we have discussed mechanism in previous lesson. Carboxylic acid, this is carboxylic acid, react with alcohol, forming ester and water. This is called esterification. Okay? And here acid derivative also used in the preparation of ester. Acid derivative, suppose RCOCl in place of ester and your H plus, your product is RCO, R gas, then that is your acid. Okay, like this, so many. So this is regarding some, that is preparation of ester. Preparation of ester from acid and acid derivative, that is called esterification. Okay, second one is ethyl reaction. Here in ethyl reaction, what happens? Aromatic, mainly it is used for aromatic alkane. So this is toluene. When oxidized by chromyl chloride, it is oxidized by chromyl chloride, CrO2, Cl2. On further, that is hydrolysis, second step of hydrolysis, the product is aldehyde, benzaldehyde. Here toluene to benzaldehyde. This is called ethyl reaction. Formation of aromatic aldehyde, aromatic alkane to aldehyde. This is called ethyl reaction. Next is Finkelstein reaction. In Finkelstein reaction, what happens? Your haloalkane Rx reacts with sodium iodide, producing Ri plus sodium halide. Here, what are X? Here X are chlorine, bromine, chlorine and bromine. So any haloalkane when reacts with sodium iodide, producing iodoalkane, here that your solvent is acetone. In presence of acetone solvent, haloalkane convert to iodoalkane. That is one. It is also nucleophile substitution reaction. Here preparation of iodoalkane, mainly iodoalkane. That is called Finkelstein reaction. Then 17, that is Fittig reaction. In a Fittig reaction, what happens? That aromatic haloarine two molecules of haloarine, then presence of sodium metal convert to dibenzene, converted to dibenzene. This is your dibenzene and this is your chlorobenzene. Here two molecules combined. This is called critic reaction. Here also same dry ether is used also. You can use dry ether. Okay, this is critic reaction. Then 18, that is Friedel-Crafts alkylation. Friedel-Crafts alkylation. Friedel-Crafts alkylation, that is same your any aromatic compound. So let us take benzene in presence of haloalkane, aromatic compound and haloalkane in presence of Lewis acid aluminum chloride producing that toluene. This is called Friedel-Crafts alkylation, electrophilic substitution reaction. That is called Friedel-Crafts alkylation. And here this is benzene and this is toluene. Higher aromatic compound can be synthesized from your lower member by Friedel-Crafts alkylation. Then 19, Friedel-Crafts acylation. In Friedel-Crafts acylation, same your toluene, that is benzene. You can take benzene in presence of acetyl chloride, acid halide, that is called acid halide. Same aluminum chloride, presence of aluminum chloride forming ketone, aromatic ketone. This is called acetophenol. This is called acetophenol. Acetophenol. This is your benzene. This is your acid halide. Acetyl halide. Acetyl chloride, acetyl halide, acetyl chloride, and produce acetophenol. This is called Friedel-Crafts acylation. Okay? Only you remember the reagent and the reactant and the product, and you have to write the name. Then we will get to 1 mark. This is some different, that is name reaction. What are the other name reactions? Let us discuss. You finish this one. Okay? Next is Fries reagent. In Fries reagent, what happens? That ester, aromatic ester, you can say. This is aromatic ester, phenyl acetate, that is phenyl acetate, in presence of aluminum chloride on heating, and the solvent is carbon disulfide. It is converted to phenyl derivative, that OH CO CH3 plus orthoposition or para-position this compound, that is ortho-para-hydroxyacetophenol, ortho-para-hydroxyacetophenol, ortho-para-hydroxyacetophenol mixture. Okay, phenyl acetate. This is one ester undergo rearrangement. That's why it's called rearrangement. Means change in position, forming orthopara. So because here O is there means it is orthopara substituted group. It is called Fry's rearrangement. Then 21, that Gabriel thalamide synthesis. Thalamide synthesis is mainly preparation of aromatic amines. If you take thalamide, this is thalamide. Thalamide first treated with yours that base potassium hydroxide is produces salt of thalamide. Potassium thalamide is produced. Potassium thalamide. Then this thalamide when treated with RX produce substituted product. NR substituted product is formed, and this substituted product undergo hydrolysis. When undergo hydrolysis, this part breaks, produce RNH2 plus phthalic acid. Phthalic acid produce phthalic acid, that is primary amine. Name is primary amine. This is phthalic acid and primary amine is produced, and this is thalamide. First step is formation of salt. Second step nucleophile substitution reaction, then hydrolysis, then produce in acidic medium and produce primary amine. This is called Gabriel thalamide synthesis. Then 22, Gatorman reaction. In Gatorman reaction, what happens? BDC, mainly BDC, N2 plus Cl minus. BDC reacts with copper and HCl. On heating, product is chlorobenzene and nitrochloride. This is BDC and produce chlorobenzene. This is called BDC converted to chlorobenzene by reaction with copper and HCl. This is called Gatorman reaction. Then Gatorman coach 23. Gatorman coach reaction. Here Gatorman coach generally benzene or any aromatic compound and treated with carbon monoxide and HCl in presence of aluminum chloride. The product will be aldehyde, aromatic aldehyde. This is benzene convert to, that is benzaldehyde. Aldehyde group can be introduced in the aromatic ring by this process. Very important reaction, that is Gatorman coach. Then haloform reaction. Haloform reaction, that is you can write also iodoform reaction. It can be prepared from any alcohol or aldehyde ketones. Here if you take alcohol CH3 CH2OH in presence of iodine and base, and the product will be here CHI3 and remaining one carbon will be formic acid, sodium formate. This reaction directly aggregate. This reaction is formation of iodoform, that is yellow precipitate. That's why yellow PPT is formed. That's why it is called iodoform reaction or preparation of iodoform. Mainly it is very important reaction to identify alcohol and aldehyde ketone, and to distinguish also between alcohol, between aldehyde, between ketones. That generally alcohol having 3 beta hydrogen atom reacts. You take aldehyde having 3 alpha, then produce CH3 and formic acid, sodium formate, iodoform. Aldehyde, alcohol, ketone all give this haloform reaction, iodoform reaction. Sometimes I2NOH can be written as NaOI. It is the important that oxidizing agent, sodium hydroxide. Okay, this is about haloform. Then Hell-Hallard-Zelinsky reaction, that is HBZ reaction. Short form, HBZ reaction is Hell-Hallard-Zelinsky reaction, and Hell-Hallard-Zelinsky reaction generally used that any acid having alpha hydrogen, acid having alpha hydrogen atom when treated with iodine and phosphorus, red phosphorus, on heating produce substituted acid, that is alpha hydrogen will be substituted by halogen. If you take chlorine, iodine, bromine, you can get, this is called HBZ, or that is Hell-Hallard-Zelinsky reaction. Any acid, it is acidic acid, convert to that iodoacetic acid, that 2-iodoethanoic acid. 2-iodoethanoic acid. That means substitution of halogen in alpha carbon, that is called HBZ reaction. Then that Hofmann ammonolysis, that is also important. Hofmann ammonolysis. Hofmann ammonolysis. You can suppose you take haloalkane in presence of ammonia, produce substituted amine. First amine is RNH2, second amine is R2NH, then third amine is R3N, and also produce quaternary ammonium salt. Quaternary ammonium salt is produced. That is formation of primary amine, secondary amine, tertiary amine can be prepared by Hofmann ammonolysis. If you start from primary amine, you can get also tertiary amine. If you start from secondary amine, you can get. So from haloalkane also you can prepare amine. That is called Hofmann. In this way, you can prepare mixture of amine. That's why in this method is very difficult to separate amines, and it is not suitable to for the laboratory method of preparation of amines. It is difficult because a mixture of amines are produced. So this is called Hofmann amine. This is haloalkane. Haloalkane convert to primary, secondary, tertiary, and quaternary ammonium salt. This is called Hofmann ammonolysis. You complete this one. Next remaining we will discuss. Okay. Then Hofmann degradation. Or this is also called Hofmann bromamide reaction. Here what happens? Any amide when treated with bromine and KOH solution on heating produce amine and KBr, then potassium carbonate. Here amide, it is amide convert to amine, primary amine, mainly primary amine. This is called your Hofmann degradation. This is very important to prepare lower amine, that is from amide. by decreasing carbon. As that is descending order. Then that is Hans-Dicker reaction. That is Hans-Dicker reaction. Here salt, that silver salt when treated with the bromine in presence of carbon tetrachloride on heating produce RBr plus, that is a bromo compound is produced, then carbon dioxide and AgPr produce. This is your silver salt of acid when treated with bromine produce hollow alkane. Generally, bromo alkane generally produced. This is called Hans-Dicker reaction, conversion of silver salt to hollow alkane. That is Hans-Dicker. Then Coles electrolysis. Method. In Coles electrolysis, if you take any salt of acid, carboxylic acid, undergo electrolysis, acute solution under electrolysis produce alkane or alkene. Here produce RR and your carbon dioxide plus sodium hydroxide plus hydrogen. These are the byproduct. Main, this is alkane. Alkane is produced. If you take that secondary compound, if you take, suppose if you take this one, that CH2, then COOH. This one, if you take CH2, COH, and it's salt, treated with salt, suppose sodium hydroxide. Second step is that is faster. Second step is electrolysis. Product will be alkene. Same carbon dioxide plus sodium hydroxide plus hydrogen. First produce sodium salt of this acid, then under electrolysis produce alkane. So this is alkane, ethane. So this is called Coles electrolytic method. Then Coles reaction, very important. Coles reaction. In Coles reaction, generally, what happens? Your phenol when treated with that sodium hydroxide in the first step, then second step carbon dioxide, then hydrolysis, followed by hydrolysis. The result is that is called salicylic acid. This is called salicylic acid. Salicylic acid is produced. This is called Coles reaction. Formation of phenol derivatives, that is carboxy derivative of phenol, can be obtained by Coles reaction. This is very important synthesis of carboxy derivative of phenol, that is Coles reaction. Then Sandmeyer reaction, 31, very important. Sandmeyer reaction. In Sandmeyer reaction, what happens? When that diazonium salt BDC when treated with CuCl, when treated with CuCl, it produces chlorobenzene. This is called Sandman reaction. Copper chloride and HCl both is treated with copper chloride and HCl and heating produce chlorobenzene. That is BDC. This is BDC and chlorobenzene. Okay, this is about Sandman reaction. Then 32, that is Stifling reaction. Stifling reaction. Here nitrile or C111 and nitrile treated with tin and HCl, then followed by hydrolysis and forming R CH, that is aldehyde. And this is your nitrile. Nitrile can be converted to SnCl2 and HCl. Here SnCl2 and HCl is used. SnCl2 and HCl will be used and produce aldehyde. Nitrile can convert to aldehyde. That is called Stifling reaction. Then trans-esterification. In trans-esterification, what happens? Here, if you take that ester, one ester when treated with alcohol in presence of acid, produce new ester and a new alcohol. This is ester, methyl acetate. This is alcohol, that is ethanol, produce ethyl acetate, new ester and alcohol, ethanol. You see change in R. This is called trans-esterification. Preparation of ester, new ester from another ester using same esterification mechanism. That is called trans-esterification. Then Ullmann reaction. In Ullmann reaction, what happens? That iodobenzene, 2 molecules of iodobenzene when treated with copper powder on heating produce dibenzene. Iodobenzene, this is dibenzene. And this is called Ullmann reaction. Then Williamson synthesis. In Williamson synthesis, what happens? If you take any halvalkane and treated with salt of sodium salt alkoxide, that's R-ONA, and the product is ROR-, product is ROR- plus NX. Ether, product is ether. Ether is produced. Ether is formed. This is your halvalkane, and this is your that nucleophile alkoxide, sodium alkoxide, produce ether. So here always halvalkane should be primary. When primary halvalkane reacts with sodium alkoxide, produce ether, ROR. That is called Williamson synthesis. That is a nucleophilic substitution reaction. Okay, to complete this one, quick you write. Remaining 2-3 reaction we will complete now. The next one is Wolff-Kishner reaction. Wolff-Kishner reactions. This is very important in the synthesis of alkane from aldehyde and ketone. Here what happens when substituted amide ketogen, when ketogen is treated with when hydrogen derivatives of that is hydrogen derivatives of ketone or aldehyde when treated with KOH and hydrogen peroxide, that is ethylene glycol and convert to alkane. This is alkane. This is your hydrazone. Hydrazone convert to alkane. KOH ethylene glycol. This is called Wolff-Kishner reaction, formation of hydrazone to alkane. But you can prepare directly from aldehyde or ketone. You can take aldehyde ketone, then you can substitute into hydrazone, then treated with KOH and ethylene glycol. The next one is that is very important reaction, that is Wood's reaction. Very important reaction you have read in junior class. That is, if you take haloalkane, 2 molecular haloalkane in presence of sodium and dry ether, you can convert alkane. Higher alkane you can prepare. Then sodium oxide. This is your alkane, higher alkane from haloalkane. This is called Wood's reactions. Formation of higher alkane from haloalkane using sodium metals. Wood's reaction. Then that next one is Wood-Splitting. Wood-Splitting reaction. Wood-Splitting reaction, here both your haloarine and haloalkane treated with sodium metal and dry ether and convert to aromatic higher alkane, that is toluene. This is haloarine and haloalkane convert to higher aromatic alkane, that is called Wood-Splitting reaction. Here we have to use both haloarine and haloalkane. If you take only haloarine, that is Splitting reaction. If only haloalkane, that is Wood's reaction. A mixture, that is called Wood-Splitting reaction. Then this is about your different types of name reaction we have discussed in alphabetical order, so it will be very easy to remember. If you start the preparation alphabetical order, you have to recall which reaction in A, B, C, D, different alphabetical order, and what are the reagent used, what are the main organic compound used in different name reactions. You practice, and the writing practice is important, and this is very important for your competitive examination and also CBSE examination. Okay, thank you all.